In this video, I will walk you through configuring the settings required for a connection to an Omron NJ or NX series controller via Ethernet IP using the top server Omron NJ Ethernet driver. Omron NJ and NX controllers are common in many process industries and support symbolic addressing similar to an AB control logics. I will cover the channel and device setup, give a summary of the settings that will be encountered, and when it is appropriate to change them from the default values. The first step in configuring a connection to an Omron NJ or NX controller from top server is to create a channel. A channel represents a communication link from the PC running top server to the device. In the case of the Omron NJ Ethernet driver, the channel represents the socket connection over which Ethernet communications will occur to the Omron controller. As a general rule for most top server Ethernet drivers, including Omron NJ Ethernet, the recommendation for the best performance is that each individual controller or device be configured on its own unique channel, allowing simultaneous communications with all channels configured, as opposed to round-robin polling of one device at a time when multiple devices are on the same channel. The Omron NJ Ethernet driver, for instance, supports up to 256 channels. So unless you have more than 256 controllers, it's unnecessary to have more than one NJ or NX controller device on a single channel in top server. You can confirm the supported channel and device count information for driver by going to Help, Support Information, and then if you click the Versions button, you select the desired driver from the list. So if I scroll down to the O's and select Omron NJ Ethernet, you'll see maximum number of supported channels is 256. So I'm going to go ahead and close out of this. And I'm going to go back over here. I'm going to click to add a channel. And here we need to select the Omron NJ Ethernet driver. So I'm going to scroll down and select that in the list. And then we can go ahead and click Next. The channel name is configurable and will be how the channel appears in the top server tree view, and is how clients will reference devices that are configured under this channel. For demo purposes, I'm going to simply call my channel NJ Ethernet. And then I'm going to go ahead and click Next. Here you can define a specific network adapter or network interface card on the top server computer. Default is the standard option, as you can see here, and allows Windows to select the appropriate network adapter for the network where the device is located based on the IP address defined for the device. So we're going to go ahead and keep that as a default here. Click Next. And here you can review the write optimization settings for this channel. And these determine the optimal method of writes based on the write queue and the priority of write operations to read operations. These will generally be left at the default value, but can be altered as needed. We're going to keep the defaults and go ahead and click Next. Here you review how the driver will handle non-normalized floating point values. This can generally be left at the default value unless non-normalized values are expected, such as not a number or infinity. If you're expecting either of those values for a floating point, you would want to change this to unmodified. But we're going to replace with 0 here and go ahead and click Next to proceed. And the last dialog summarizes the selected channel settings and also provides the ability to tweak the settings right here in the summary if you notice something's incorrect. So I'm going to expand this so that we can see all of our settings. Now you'll notice that the channel name is in bold. That indicates a change from the defaults. So since that's the only thing we had to change from the defaults, everything else is not bold. So all of our settings are correct. So I'm going to go ahead and click Finish to finalize the configuration and create the channel. Now that the channel is complete, we need to add a new device to the channel. So we're just going to click to add device. And the device name is user configurable as well, and is how the device appears in the top server tree view, and how client applications access that device under the channel. For this demo, I'm just going to call my device NJ for simplicity. I'm going to go ahead and click Next. Here we specify the device ID of the NJ or the NX controller itself, which is typically just the IP address assigned to the controller. If it's a direct connection to a local NJ or NX controller without any CIP routing through one controller to get to another. Alternatively, this driver also supports dynamic hostname resolution in the event that your network administrator has assigned a DNS hostname to your controller. If you do need to route to a remote NJ or NX controller through another NJ or NX controller, the driver does support that. You can consult the Omron NJ Ethernet driver help file, and I'm going to go ahead and launch that right from the context sensitive. And you'll see under the setup section of that help file, there are routing examples, connection path specification that provides details on how you would specify a routing path, a CIP routing path, if you were having to use that for communications. For our purposes, we would be making a local connection, so just the IP address is required. So I'm going to go ahead and specify an IP address of 192.168.111.1 for our NJ controller and click Next. Now we need to specify the device's scan mode settings for subscription-based clients. In systems where bandwidth utilization is not a concern, this setting should be left at the default of respect client specified scan rate. Other options include, and I'll click the drop down just so you can see what those are. Now, respect client specified scan rate, which is the default, simply respects the requested scan rate from client applications to determine how often to scan the device for the tags being requested. Request data no faster than sets a ceiling. Data will be requested no faster than the specified time frequency. Request all data at means all data will be requested at the specified timing frequency, regardless of the update rate the client's asking for. Do not scan demand poll only means there will be no automatic scanning done of the device unless a plugin or client application manually triggers the poll via a special system tag called _demand poll, which is available for each device. And then we have respect tag specified scan rate, which respects the scan rate that is specified at the tag level when you define static tags in the top server configuration. For the purposes of the demo, though, I'm going to go ahead and leave the scan mode at the default, since that is generally the recommended setting. And I'm going to go ahead and click Next. The timing settings, as you can see here, should be set appropriately based on the level of congestion on your network. I'm going to go ahead and expand this so we can see all the settings in one window. These can generally be left at the default to start, and that is what we tend to recommend. And then those can be increased or decreased as needed. For instance, if you're seeing a lot of connection timeouts to the device, you may want to increase the connect timeout to give the device more time to accept the socket connection that this driver is trying to make to it. If you're actually getting a socket connection, but you're seeing a lot of timeouts waiting for a response to your requests, you may need to increase the request timeout to give the device more time to respond. That does default to 1,000 milliseconds or 1 second. So if you think it might be taking your device a little longer to send back responses than 1 second, increasing that request timeout can help resolve that. The goal is to have the timing settings as low as possible while still maintaining successful communications. This allows the driver to detect actual communications issues more quickly. You can see here you can also specify an inter-request delay, which inserts a delay between requests to the device. This can be useful for slower devices where it's necessary to give the device more time between requests to prevent overloading the device. But for our purposes, like I said, it's typically recommended to maintain the defaults here, so we're going to go ahead and maintain the defaults and click Next. The auto demotion settings determine whether unresponsive devices will be taken out of the polling cycle for a channel for a specified period of time. In situations where multiple devices are configured under a single channel, which is normally not the case with most Ethernet drivers, including this one, if you do have a situation where, like I said earlier, if you have more than 256 devices, you would have to have more than one device on a channel in that situation. So in that situation, it is recommended to enable auto demotion. I'll go ahead and enable it just so you can see the settings. So in that situation, it's recommended to enable auto demotion and enable discard write requests while it's demoted. Otherwise, write requests will override the auto demotion period and attempt a connection immediately. This setting basically timeouts to demote. So if we've sent a request and not gotten a response 3 times in a row, and that's happened 3 times, that's based on the prior timing settings. So if we've gone through that sequence of trial and retrials 3 times, then we're going to demote that device at that point. And we're going to demote it by default for 10 seconds, 10,000 milliseconds, before we attempt to try to communicate with it again. So those are just the defaults. These can be set to whatever is necessary based on either how frequently you think a device is going to be unavailable or how long you think it'll be down when it is unavailable. But like I said, since in most situations you're only going to have one device on a channel anyway, auto demotion doesn't really come into play for most scenarios with Ethernet drivers. So I'm going to go ahead, since we are in that situation where I'm going to have one device per channel, I'm going to go back and disable that again, keep that at the default, and I'm going to go ahead and click Next. Here's where you specify some parameters related to automatic tag generation. The NJ Ethernet driver can be configured to automatically generate tags for the variables that are available in the NJ controller, NJ or NX controllers. Actually generating the tag database is completed after you're finished configuring the device properties, though. The settings that you can see here determine if and when the tag database will be created, how previously generated tags will be handled, and if tags should be included in a specified parent tag group. This parameter keeps automatically generated tags from mixing with tags that have been entered manually. Keeping these settings at the default is generally recommended. Since the actual import process is completed later, after the device configuration is completed, we're going to keep the defaults here and go ahead and click Next. And here we specify some device and protocol specific communications parameters. The TCP/IP port number defaults to 44818, which, if you're familiar with ControlLogic's communications, that's the same port that you'd use for ControlLogic, since this is also CIP over Ethernet, and that is the standard port for CIP over Ethernet, which is a form of Ethernet IP. Unless your Omron NJ or NX controller has been configured to use a non-standard port number, you want to leave this at the default of 44818. Then we have some CIP protocol specific settings. The connection size, specified in bytes, defaults to the maximum allowed of 1,996 bytes. It is recommended to leave this at the maximum size for the best performance. And the inactivity watchdog timer defaults to 32 seconds. This is the amount of time the CIP connection to the controller can be idle with no traffic before the driver will close that connection. 32 seconds is generally long enough and should be left at the default in most cases, even though you can see you can bump that all the way down to 8 seconds or all the way up to 128 seconds. We're going to keep the default to 32. And last but not least, we have the array block size, which defines the maximum number of array elements to be read by the driver in a single transaction. This defaults to 120 elements, which is typically fine for most applications. But if you're extensively using arrays in your controller, the maximum goes all the way up to 3,840 elements per transaction. So you can increase it from the default if necessary. For our purposes, we're going to go ahead and retain the default and click Next. Here we can define whether or not performance statistics should be collected by the driver, such as update performance and other metrics. These metrics get logged to the top server event log after the server is shut down or after this setting is set back to disabled again. The metrics can be used for fine-tuning the performance of the configuration. However, be aware that there is also additional overhead involved when performance statistics are enabled. So it is recommended to keep these disabled if you're not trying to measure performance and tune the performance of your connection, because you're ultimately going to have better performance with the statistics disabled. So for our purposes, we're going to keep these disabled at the default. And we can also define how we want the tag hierarchy to be organized in the tree view here on the left in top server under the device after we've auto-generated tags. And I'll expand so you see the options. There are two options here. The condensed method results in fewer tag groups being created. However, expanded is the suggested default since it gives you a more logical group hierarchy. So we're going to go ahead and keep the default and click Next. Here we can review the device settings in the summary for correctness and make any necessary tweaks. Again, you'll notice some settings in bold, which are the only ones we changed from the defaults or entered for blank fields, which in our case is only going to be our name of NJ and our IP address for the device ID. So we're going to go ahead and click Finish here to create the device. You see my device got created. Now we can open the properties of the newly created device by double-clicking on it. So I'm going to double-click on NJ. And I'm interested in the tag generation section. So I'm going to go to the tag generation to revisit the automatic tag generation process that we discussed earlier. To auto create tags, you click the Create Tags blue link that you can see here. That's going to start the automatic tag generation process. In this demo, unfortunately, my Omron NJ isn't available for a connection at this time, so I am going to have to skip that step. So we won't click the Create Tags, but in your scenarios where you have an NJ or an NX available and you configure the device properties and you're ready to auto-generate tags, you go into the device properties, go to Tag Generation, and click on that link to start that process and suck in all the tags from your NJ or your NX controller. So alternately to automatic tag generation, you can also choose to define static tags manually in the server by clicking Click to add a static tag, if so desired, or the top server also supports dynamically specifying addresses in the client application under the configured device using just the proper address instead of a static tag name. For help with the proper addressing syntax, the Omron NJ Ethernet driver help file should be referenced. So if I click help here, I'm actually going to go up to my help menu, driver help, and if I go to Omron NJ Ethernet, you'll see there's a section called Address Descriptions and Address Formats, and this provides all of the information on the valid syntax for addresses in an NJ or NX series Omron controller. Since these controllers do use some symbolic tag name referencing, as I discussed earlier, it is ultimately best to use automatic tag generation if at all possible, just to ensure accuracy of those tag names. So this video has shown the general steps required for quickly configuring an Omron NJ or NX series controller in Top Server version 6 for process data collection. It is not intended to be a comprehensive how-to regarding the Omron NJ Ethernet driver, and the Top Server Omron NJ Ethernet driver help file should be referenced for further information.